Alright, so I am out for a doctor's appointment, so I flipped this lesson. I apologize in advance for my voice. I have lost my voice, and I apologize in advance for all the coughing that I will probably do. So today we're going to be looking at how to write the formulas for ionic compounds. So the worksheet that you picked up today, you will only be doing the backside, number 22 through 42. And then we'll do the other side tomorrow. I also want to remind you that you do have your Ion Quiz 1 tomorrow. So let's get started. For ionic compounds, the first ones we're going to talk about are binary ionic compounds. Those are the ones that are going to be just a metal and a non-metal. When we're writing them, the cation, which is the metal, always comes first, and the anion always comes second. Remember, the cations are positive, and so they will always come first when we're writing the formulas. When we're doing this, we're going to put these together in a way that we determine the smallest whole number ratio of cations to anions that would make the charge be 0. Okay? So to determine which ions are going to form, there's one of two ways you can do this. Obviously, you can look at your ion list, but I want you right now to look at the periodic table on the other side of the ion list, and we're going to label each group, the periodic table, with what charges that they will always be. I say each group, actually, we're going to do the groups that you can tell them based on the periodic table. So if you look at group 1, the alkali metals, they have 1 valence electrons, so they will always be a +1 charge. So above group 1, write +1. So everything in group 1, from sodium, potassium, everything, all of those are always going to be a +1 no matter what. Hydrogen does not fall into that category. Group 2, the alkaline earth metals, they have 2 valence electrons. They like to give them away. So everything in group 2 is going to be a +2. So above that, write +2. Okay? So for the transition metals, you cannot actually look at the group number to figure them out. You actually need to look those up because the transition metals have the ability, the majority of them, to form more than one charge. So when you look at your ion sheet and you see things like copper with a parentheses of 1, copper with a parentheses of 2, it's literally telling you what the charge is. And that's because they have the ability to do more than one charge. The exceptions of the transition metals are zinc and silver. They have specific charges that are on your ion list that you will have to memorize. If you look at group 13 now, group 13 has 3 valence electrons, and they will form a +3, so write +3 at the top. For group 14, we're not going to write a number at the top because they can do different things because there's metals, nonmetals, and metalloids. Carbon at the top tends to share all the time, along with silicon, but if you look at the bottom of that group, tin and lead can actually be a +2 or a +4, and so we would need to know based on the Roman numeral what they are. Now going to group 15, group 15 is going to be a -3 or a -3 charge, and that's because they have 5 valence electrons and they will take in 3. Excuse me, group 16, oxygen and sulfur are always going to be a -2 charge in there. And then group 17, the halogens, will be a -1. So that's a way you can look and kind of see without having to memorize, which will also help you when you're doing your ion quizzes. Okay? So let's get started on how to, let me go back just one second. If you look down here, oops, sorry about that. If you look down here for hydrogen, remember that hydrogen can either gain, lose, or share an electron. And so they can do all 3. Most of the time they will lose and be a +1 charge, but you need to be aware that they can also lose and share. All right, so here we go with how to balance these out. Remember, we want our charges to be equal to 0, so our positives and our negatives have to be the same. So in this case, I had sodium, which is a group 1 metal, and it's got a +1, and then chlorine has a -1. And so we're going to put those together as a NaCl because they're already balancing themselves out and their charges are equal to 0. But if we look at the next example for aluminum oxide, aluminum is a +3, oxygen is a -2. So we need our charges to balance out. We need to have the same number of positives and negatives. So when we see one like this, the best thing to do is look at that and say, what is a multiple of 3 and 2? And of course, a multiple of 3 and 2 is 6. So if I can get aluminum to be a +6 and oxygen to be a -6, their charges will bounce out. So I look at aluminum and I say, what times +3 would give me a +6? And we see that it's 2. So we would say Al2. And then I look at oxygen and say, what times -2 would give me a -6? And that would be 3. So now I would need 3 oxygen and 3 oxygen and 2 aluminum. So that would be my formula, and my charges would now equal 0. So let's do a few examples for you. So when you're doing your worksheet today, remember we're just doing number 22 through 42, and I encourage you, while you're learning to do this, to go ahead and write the charges out individually and then see how they go together. So magnesium, group 2 metal, so we're going to say magnesium +2. If we look at phosphide, remember when we have that IDE, it's just the element, so that means it's going to be phosphorus, and if we look at that, it's in group 15, so it's going to be a -3. And so I would look at that and see how do I want to put that together. Again, 3 and 2, so I have a multiple. So I want to make them both be 6. So that means I would use 2 magnesium and 3 phosphorus. So that would be my formula. For iron 2 bromide, this 2 is telling me the charge of iron. It's not saying that I have 2 iron. It's telling me that my iron has a +2 charge. Okay? And then bromide is a -1 charge because it's a halogen. So then I would look at those and say, okay, I've got a +2 here and a -1 here, and so I would need 1 iron and 2 bromine. So that would be my final formula. Notice when I'm writing the final formula, I am not writing down any charges. Okay? Next one is calcium oxide, Ca +2, because it's a group 2 metal. Oxygen is in group 16, so that'll make it a -2. And as you can see, those charges are already even. I've got a +2 and a -2, so I would just write down CaO. Sodium sulfide is the next one. Sodium is a group 1 metal, so it'd be Na+. And then sulfide is a group 16, so it'd be -2. And so I have a +1 and a -2, so I would need 2 sodium, so that would equal +2, so it'd be 2 sodium, 1 sulfur. Copper 2 iodide, again, that Roman numeral is telling me that copper has a +2 charge. And then iodide is a halogen, so it's going to be a -1. So in this case, I would need 2 iodide to go with 1 copper. And then lead 4 nitride would be lead +4. And then nitride is in group 15, so it's a -3. So again, now I have a 4 and a 3, so I want to do a multiple of 4 and 3, which would be 12. So if I do that, that means I would need to use 3 lead, and I would need to use 4 nitrides. Okay? And then the last one is aluminum nitride. So Al is a +3. That's one of the ones you need for your ion quiz tomorrow. We just did nitride, which is a -3. And since they're already a +3 and a -3, that formula would just be AlN. Okay? So that's how you do if it's just a metal and a non-metal. On the next examples, we're going to do ionic compounds that are using the polyatomic ions. And remember, polyatomic are covalently bonded, but they have a charge. Okay? And so those are going to be the ones on your pink sheet that are in brackets. And we don't normally write the brackets. I did those so that you would know that they are one thing. For instance, nitrate is NO3 -1. That means this whole thing is a molecule, okay, stuck together, and the whole thing has a -1 charge. So once we write down that NO3, we're not going to ever change the subscript, okay? So let's keep that in mind as we go through for the examples. So here we have sodium and phosphate. Sodium is a +1, phosphate's a -3. So I'm going to need 3 sodiums to go with one of the phosphates. So I would write that as Na3PO4. And notice when I only need one that I don't include the parentheses. Okay? On the next example, I have ammonium sulfide. Ammonium is NH4, and the entire thing has a +1 charge. Sulfide's in -2. The IDE indicates that it's an element, okay? So because this is a +1, I'm going to need to use 2 of those to equal this -2 over here. So when I have to use more than one, I don't change any of the subscripts. I throw parentheses around that NH4 and say that I have 2 of them, like right here, and then so that would be my formula. Okay, so let's do some examples. All right, we're only going to go to, I think your paper only goes to right here. So we're only going to go to right there. We're not going to do those last ones. So aluminum, we just said a while ago, aluminum is a +3. If you look up sulfate on your ion sheet, you'll see that it's SO4, 2 minus. Okay, so I need to put those together. So I'm only going to be looking at these charges up here. Okay, I don't care about this 4 down here. I'm only going to be looking at the charges. And I have a 3 and a 2, so that means I need a multiple of 6. So my formula would be Al2, and then I'm going to need 3 sulfates. So I'm going to put parentheses around them, put my SO4 inside, and put the 3 outside. Okay? Potassium chlorate, potassium group 1 metal. If you look up chlorate, you'll find it in the ion list. It's in the second grouping for ion quizzes, and it's ClO3. The entire thing is a -1 charge. So the fact that I already have a +1 and a -1, they're just going to go together 1 to 1, one of each. KClO3. Copper 1 acetate, copper 2 acetate. It's telling me that copper 2 plus charge. Acetate, you can find that on your ion sheet. I believe it's in the 5th list that we're testing on, and it is C2H3O2, and it's a -1 charge. Because of that -1 charge, I need 2 of them to go with 1 copper. And so it would be Cu parentheses C2H3O2, and you need 2 of them. And then the last one is lead 2 nitrate. So that 2, Roman numeral, is telling us that we have a +2 lead. And then nitrate, you look that up. I believe it's in group 4 that we're testing on, and it's NO3 minus. And so it's a -1, lead is a +2, so I will need 2 nitrates to be able to go with 1 lead. So that formula would look like this. Okay, so do the best you can today. I know, I'm sorry I'm out. Miss Lawrence is here. She's covering for me, so she can definitely she can definitely answer any questions that you might have. You're supposed to finish this side of the worksheet today. Tomorrow we will be doing the other side. And again, I want to remind you that you have Ion Quiz 1 tomorrow. I apologize for making you listen to my raspy, gross voice, but it couldn't be helped. I will see you guys tomorrow.